Hello, welcome to this first video for Math 107. Today we're going to talk about units, or at least the first part of our idea with units. Often in mathematics, we would like to convert from one unit of measurement to another. For example, suppose you have a Ford 150 truck, and its weight is 4,928 pounds. The units here are pounds. Pounds are a U.S. customary unit for weight. Or another example is you might be 48 years old. Well, here the unit is years. We're measuring time, the time that you've been alive. The process of converting from one unit of measure to another is called dimensional analysis. To use dimensional analysis, we often need what are called conversion factors. Now, conversion factors are not something you need to memorize. In class, I'm going to give you this rather extensive list of conversion factors. So you can use them at any times, and I'll be referring to this throughout this video. Let's do an example. What is the weight of a truck at 4,928 pounds in tons? To do dimensional analysis, the first thing that I do is write down what I'm given, which is 4,928 pounds. The abbreviation LBS is the standard abbreviation for pounds. Now I need a conversion factor. So I'm going to go to my list here, and I'm going to see if I can find a conversion factor here for pounds to tons. Well, I found one right here. This one, which I'll zoom in a little so you can see, says that 1 ton is 2,000 pounds. That's an equivalency or a conversion factor. So let's go out again and let's use that. So my conversion factor is 1 ton equals 2,000 pounds. Now realize that this conversion factor gives us two possible fractions. One fraction is 2,000 pounds over 1 ton equals 1. Another factor is 1 ton over 2,000 pounds equals 1. Now everybody knows that when you multiply by 1, you don't change the values. So what I'm going to use is I'm going to use one of these two conversion factors to convert this to tons. Now since I want tons and I want to get rid of pounds, I'm going to use this conversion factor. I'm going to put pounds on the bottom, the 2,000 pounds, and tons on the top. Now that way the pounds divides out and the tons is what we have left. And our problem becomes 4,928 divided by 2,000 tons. Now that's not really a very useful answer, so I'm going to use my calculator to help me out here. So I'm going to take 4,928 and divide it by 2,000, and that gives me 2.464. So this is 2.464 tons. Now remember from your previous math classes that you might be asked to round. If this problem said, oh, what is that rounded to the nearest tenth? I might go to this and say that that's approximately 2.5 tons. So that's the basic idea of dimensional analysis. Let's do a few more problems. An elephant weighs 6.75 tons. What is that weight in pounds? So I want to start with 6.75 tons, and I know I want pounds. So I'm going back to that conversion factor again we had before, which was the 1 ton is 2,000 pounds, or 2,000 pounds over 1 ton, or 1 ton over 2,000 pounds, both equal 1. So this time, I want to get rid of tons, so tons is in the bottom, and pounds are on the top. And this problem is as easy as just taking 6.25, or 6.75, excuse me, times 2,000. And if I do that again on my calculator, I get 13,500 pounds. Now, in both of these examples, I converted from one unit of measure to another equivalent unit of measures. Sometimes you have to do a lot of intermediate steps, what we often call a chain of conversions. For example, here's a question. How old in seconds is somebody who is 48 years old? So I'm going to start with 48 years, and I'm going to turn that into seconds. Now, units of time, I assume you know from just your general experience. And you probably don't know, however, how many seconds are in a year, but you probably do know that there are 365 days in 1 year. So if I want to get rid of years and put in days, I would do this. And this multiplication right here will give me how many days are in 48 years. And you probably also know that there are 24 hours in 1 day. So this conversion would allow me to divide out days and have how many hours there are in those 48 years. And you probably also know that there are 60 minutes in 1 hour. And you also probably know that there are 60 seconds in 1 minute. Now this here is a conversion, a chain of conversions, where you would eliminate years, eliminate days, eliminate hours, eliminate minutes, and finally have seconds. So your answer is 48 times 365 times 24 times 60 times 60. Let's do that calculation. And that ends up to be 151,372,8,000, or 1,513,728,000 seconds. So if you didn't feel old before, you probably do right now. Here's an example of another one where we would need a chain of conversions. You make a scale model of the solar system, and you decide to use 1 inch for each mile. You look up the distance from the Earth to Mars and realize that it's 249 million miles. So for your model, you'll need 249 million inches to represent that distance from Earth to Mars. What is 249 million inches in miles? So I'm going to start with 249 million inches. And again, I probably don't have a conversion from inches to miles, but I do have a conversion on my conversion sheet from inches to feet. And 1 foot is 12 inches. And again, I would put inches on the bottom to divide out inches and turn in feet. And 5,280 feet to 1 mile. So here I will put 5,280 feet in the bottom again to divide out feet. So here I'm going to take that 249 million, I'm going to divide it by 12 and divide that answer by 5,280. Let's do that right here. 249 million divided by 12, and then I want to divide by 5,280, and I get approximately 3,929.9 miles. So as you can see, using this 1 inch to represent each mile in your scale model isn't a very good idea. This is approximately the distance across the United States of America, and that's just the distance from the Earth to Mars. Sometimes when we use units like miles per hour or miles per gallon. These units are called grades. And when we say the word per, we usually mean division. Let's look at how this works. This is very similar to the previous problem, except we often have to convert not just 1 unit, but 2. Let's convert 45 miles per hour to feet per second. So 45 miles in 1 hour. And I want to convert to feet per second. So you notice I need to get rid of miles and turn in feet. So I'm going to go to my conversion factors again, And I'm going to look and see if I have that. And I do have a conversion factor up here. Again, I'll zoom in for you. Of 1 mile equals 5,280 feet. So I could go ahead and use that one to eliminate miles and put in feet. This time the 5,280 feet go on top and miles are on the bottom so that the miles may divide out. Now I have feet per hour, but I don't want feet per hour, I want feet per seconds. So I have to convert hours to second. I may not know how many seconds are in an hour, but I do know that there are 60 minutes in 1 hour, and that would give me now feet per minute, but I'd like to get rid of minutes and put in seconds. So I have feet per second finally. So my numerator is 45 times 5,280. My denominator is 60 times 60. Let's see how to do this on my calculator. So I'm going to start with, let me put parentheses, 45 times 5,280 in parentheses, divided by parentheses 60 times 60. The parentheses are important here because I don't want to just divide the 5,280 by 60. I want to divide it by 60 times 60. So I put parentheses around my entire numerator and my entire denominator. That ended up to be 66 feet per second. So this is a conversion where we had to deal with not only the unit in the numerator, but also the unit in the denominator. But the same idea, deciding what I started with, what I want, and using conversion factors to help eliminate the appropriate units until I get what I want. An interesting example is rates in foreign currency. Typically, when you go to a foreign country, you need to change to that type of currency in the country. One common currency in Europe is the euro. Many countries in Europe use the euro. And an exchange rate is a rate that changes daily between two different units of currency. Looking up today's exchange rate, 1 euro is equal to $1.08. So if you go to another country like France and you see that you buy a can of soda and it's 2.5 euros per 500 milliliters, you might want to compare what would that price be in the United States. But in the United States, you wouldn't use euros, you would use US dollars. And you wouldn't use milliliters, you'd probably use ounces. So we're going to start off with 250 or 2.5 euros per 500 milliliters. Okay, you'll notice, unlike the previous example, I have a value in this rate for both the top and the bottom. And I want to convert euros to dollars. So I want to have dollars up here and euros down here. This, by the way, this funny looking E is the symbol for euros. Now you notice it says 1 euro is $1.08. Okay, so we'll put that in. That would give me how many dollars this costs per 500 milliliters. Now I would need milliliters to ounces. Let's go and take a look at my conversion chart again. So here I have 1 fluid ounce is 29.574 milliliters, or 1 milliliter is 0.03381 fluid ounces. I can use either of one of these I want. I think I'm going to use this one right here. So I would like milliliters on top, so those would divide out, and I'd like ounces on the bottom. I'm just going to write OZ for fluid ounces. And there's 1 fluid ounce is 29.574 milliliters. So let's do the arithmetic again to do this. This final answer will be in dollars per ounce. So that would be 2.5 times 1.08 times 29.574 over 500 times 1 times 1. Okay, let's do that. So the numerator was 2.5 times 1.08 times 29.574. Notice I put that whole thing in parentheses, and then divided by 500. And that gave me approximately 16 cents per ounce. So $16.0.16 per ounce. Now that may seem like a lot, but remember, soda doesn't usually include just 1 ounce of soda. You might have a 16 or an 8-ounce soda. If you looked at that for 8 ounces, that would end up to be about $1.30 for an 8-ounce soda there. Okay, let's take one last look at units. In this way, we're going to look at units with the idea of area. So here's a problem. Suppose you wish to carpet a room which is 20 feet by 30 feet, with carpet costing $7.50 per square yard. How much will this cost? Well, when we measure area, we can't use linear units like inches or feet. After all, we're trying to measure a two-dimensional object with something that is one-dimensional. So we're going to use something called square units. What a square unit is, well, here, look at this example. This is about 1 inch by 1 inch. That's a 1 inch by 1 inch square, and that's called 1 square inch. If I measure area, I'm counting how many of these square inches fit inside of my space. Notice this is two-dimensional, just like area. Conversion factors work, however, a little bit different. Let's try to think about how many square feet are in a square yard. Well, here's a picture I've drawn, not to scale, obviously, but a picture of a square yard. So this is a square yard and a square yard right here, 1 yard by 1 yard. And we know that each yard is made up of 3 feet. So this is 3 feet by 3 feet. So this would be 1 foot, 1 foot, 1 foot, 1 foot, 1 foot, 1 foot. So this right here might be 1 square foot. And so would this. And so would this, and so on. How many of these do I have? Notice I have 3 times 3, or 9 square feet. Now the easiest way to do this, if you know the linear conversion factor, 1 yard equals 3 feet, then all you have to do is square these to get the area squared factor of 1 square yard equals 9 square feet. So now I can solve this carpet problem. My carpet problem was I have a 20 foot by 30 foot room. If I multiply 20 times 30, I end up with 600 square feet that I need to carpet. So I need 600 square feet, and I want to get rid of square feet and turn that into square yards, because that's what my carpet is sold in, square yards, not square feet. I know that 1 square yard equals 9 square feet, so I'll put 9 here and 1 there. And this right here will give me my area in square yards. And I know that my cost is $7.50 per 1 square yard. So this will give me my total cost. If I do this calculation, which is 600 times 1 times 7.5, divided by 9, I end up with $500 that I would spend to carpet this room. Similar to the problem of area is the problem of volume. Volume is 3-dimensional, so you need a unit that is 3-dimensional, and the unit that we use is cubic units. For example, this is about 1 inch by 1 inch by 1 inch, so this is called 1 cubic inch. What is the conversion factor from cubic units if we know the linear conversion factor? Let's start again with 1 cubic yard. We know that 1 yard is 3 feet. So each of these, if I drew this picture here of a cubic yard, I can divide up into 1, 2, 3 feet. I would have a picture that sort of looks like this. Kind of looks like a Rubik's Cube. I draw all of it in here. Now, how many cubic feet, there's a cubic foot right there, are in here? You'll notice there's 9 in each row, and there's 3 rows, so there's 27 cubic feet. Now again, remember, 1 yard is the same as 3 feet. That's the linear measure. To turn that into a measure of volume, we just cube everything, 1 cubed and 3 cubed, and I have the appropriate units for volume. So, for example, how many cubic inches are in a cubic yard? If you know that 1 yard is 36 inches, which if you don't know is on my conversion chart, okay, I then know that 1 cubic yard is 36 cubed cubic inches. And 36 cubed, according to my calculator, is 46,656 cubic inches. Okay, let's do a problem with a couple of problems involving volume. A new sidewalk is 3 feet by 250 feet by 6 inches. All right, so let's take a look at a picture here. Again, not drawn to scale, but you'll get the idea. 3 feet, 250 feet, 6 inches. Now the first thing is these linear measures have to agree. So I'm going to convert 6 inches to 1/2 a foot. And then to calculate my volume, I just do length times width times height, which is 3 times 250 times 1/2. So if I do that calculation, 3 times 250 times 1/2, I end up with 375 cubic feet. Notice feet times feet times feet gives me cubic feet. Now if I want to know how many cubic yards that is, I need to take that 375 cubic feet and delete the cubic feet and put in cubic yards. Now remember, 1 cubic yard is 27 cubic feet. We did that on the previous page. So if I take 375 and divide it by 27, I get approximately 13.9 cubic yards. Here's one more problem that involves a lot of conversion. A basin is 3 feet by 4 feet by 6 feet. Okay, so I'll kind of draw a picture here. So 3 feet by 4 feet by 6 feet. The volume of this basin is then 3 times 4 times 6, which is, let's see, 3 times 4 times 6 is 72 cubic feet. I'm filling this basin with water. I now want to know what is the amount of water in gallons that I can put in here. So I can fit in 72 cubic feet of water, but I need to find the conversion factor for water feet to gallons, which again is in my chart. So I've given it to you here. 1 cubic foot is 7.48 gallons. So I want gallons on top and cubic feet on the bottom. So this would eliminate my cubic feet and give me gallons. So if I do that calculation, I end up with about 538.6 gallons of water. I hope you have found this video useful.